Hello class, this is Ms. Daniels coming to you again with a new video. We're going to be talking about place value and understanding power of 10 and base 10. Make sure you have out your any notes that you may want to take. I will be sending this, posting this on my channel, and I will be updating a Google shared document so that you guys can also access the lessons through that shared document. So if you have any questions, be sure to leave them in the comments, or you can also message me on Remind. All right, let's begin. So when you are in preschool or before you started school, maybe at home with your parents or what have you, you learned base 10. When we think about base, we think about the base of something, the actual foundation. So our foundation of learning numbers starts with base 10, being able to count from 1 to 10. And everything from there goes up. When we start counting from there, we say, okay, I've done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then next it'll be 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, which is the same as, it's the same as saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However, we have increased it by 10. So when we talk about base 10, we have to understand that all our numbers are based on the idea that 1 through 10 is the foundation of where we actually learn how to then build on from there, okay? All right, so let's talk a little bit more about this whole base 10, because base 10, we can then power numbers up or power numbers down based on multiplying it by 10 a certain number of times. So we call that power of 10. So we talked a little bit about exponents and how exponents work when we are using exponents. You won't really get into exponents a lot until 6th grade, being that they've kind of changed the curriculum around. So be prepared for that. But we did talk about exponents and how they work. And an exponent is basically multiplying that number by itself, however many times that exponent tells us to. So in this case, when we're looking at the base 10 and this exponent here, we understand, okay, this is multiplying. That means we have 110, right? It's telling us how many 10s we have. So in this case, we only multiply it by 1 because we only have 110, okay? So that we say that by saying 10 to the power of 1. So that means I only have 110, okay? And then next we say 10 to the power of 2. That means I multiply 10 twice. That gives me 100. So I've increased my value here to 100 just by saying 10 to the power of 2, which means 10 times 10. And here we have 10 to the power of 3, meaning multiply 10 3 times. 10 times 10 times 10, which gives us 1,000. Or we have 10 to the power of 4, which is multiplying 10 by itself 4 times. 10 by times 10 times 10 times 10. Now we are not multiplying 10 by times 4. We're not multiplying 4 times 10. We are multiplying. This exponent tells us how many times we need to multiply 10 by itself. So do not confuse the two, okay? So 10 to the power of 5 would be saying 10 times 10 times 10 times 10, which gives us 100,000. Now, another way to look at this as well is to say, how many zeros or place values is it giving me? Is it adding to my place value chart? Okay, so in this case, I have 10 to the power of 1. Okay, so I have 1 0. I have 10 to the power of 2. Okay, I have 2 zeros. 10 to the power of 3, I have 3 zeros. 10 to the power of 4, okay, I have 1, 2, 3, 4 zeros. So, and 10 to the power of 5, I have 5 zeros. So that means when I multiply or when I'm doing powers of 10, my place value should be increasing the value of my given number or the number that I started with. I should be increasing it by these many place values, okay? And if I don't have that many place values in my number that I've increased this number, my initial number by, then I must have did something wrong. So you want to make sure that you look at your place value and that it matches exactly the place value of what the power of 10 should be. So I can say 10 to the power of 2, or I can say 100, okay? I could say 10 to the power of 3, or I could say 1,000. I could say 10 to the power of 4, or I could say 10,000. I could say 10 to the power of 5, or I could say 100,000. Okay, those are equivalent. They mean the same. They are the same thing. Okay. Now, so how does that work when we're talking about the place value chart and those our numbers moving around when we're talking about in relation to a decimal there? Okay, so in earlier grades, third, second through fourth grade, you learned our what's in front of, or the whole numbers in our place value chart, which is your ones, your thousands, your millions. And in this case, this chart has billions, but we don't really mess around with billions too much in fifth grade. But we really don't mess around with millions too much either. However, it's important to know at least millions and billions do exist, right? So in this case, on this side of our decimal, we are dealing with whole numbers. These are whole units. These are whole values, okay? If I have $1, I have a whole dollar, right? Now, on the other side of my decimal, here's my decimal here. If you're following my arrow, my pointer, there's my decimal there. Then on the other side of my decimal, I get into smaller pieces of wholes. Just like in fractions, we talk about fractions and decimals in class. They're essentially, the same thing, right? I can have 1/10 or I can have a tenth, right? And so in this case, we're talking about decimals. So if a place value or a number falls in this place value, we know that that is 2/10, right? And we also can write that with the 2 on the top and the 10 on the bottom, just like the 2 as the numerator and the 10 as the denominator. We talked about understanding how those are related when we're talking about fractions and decimals, okay? So in this case, if I'm writing a decimal, then I would put my 2/10, meaning that I will put 2 in the tenths place. And if I'm talking about 300ths, which is your numerator is a 3 and your denominator is 100, right? That's 300ths. That means I will put my 3 in the hundreds place. And so it's the same, or so it's true for the thousands place, in which if I had a number that represents the numerator as a 6 and the denominator as 1,000, then I would put the 6, that would be 6,000s, in which I would put the 6 in the thousands place, okay? Now, also, it's very important for you to understand the values of this thousands, hundreds, and tenths, because these are pieces of a whole, okay? So just like I can have a whole dollar, or I can have 10 cents, which is 1/10 of a dollar, right? Or I can have a penny, which is 1 cent, or 1/100th of a dollar, meaning it would take 100 of those pennies to give me 1 whole dollar, or it would take 10 of those 10 cent or dimes to give me 1 whole dollar. So that's why they're in the 10th place. That's why a penny would be the same as putting something in the hundredths place, okay? And the way we will write 1 cent would be decimal 0.1, right? So that's exactly the same as how we look at our place value chart in relation to money, okay? So I know you guys like money. So if you know money and understand how money works, then you also understand how our place value chart works in determining the value of that money, okay? So now let's go back to how these place values change. Power of 10 can change those place values, okay? So if I want to increase my place value, then I would move from the right to the left. So that means the thousands, okay, is smaller than 100ths, and it goes up to tenths, and then it increases to ones, then tens, then hundreds, then 1,000, 10,000s, and 100,000s, and so forth and so on into the millions and billions. From left to right, it increases, right? And then if I wanted to decrease, meaning making my value of the number smaller, then I would go from the billions or the millions from the left to the right. So that means these numbers or these values tend to get smaller and smaller. Now, how, Miss Daniels, is 1,000s smaller than 100? So, okay, say if you had a cake, right, and you're at a birthday party, and you had 1,000 people to divide that cake up to. All those 1,000 people are going to get smaller pieces of that cake because you have to divide it up more times. Whereas if I had 100 people coming to my party, well, then I only have to divide my cake 100 times, meaning the pieces are going to increase in size. I can be able to give out a little bit bigger pieces, right? And if I had only 10 people show up to my party, then they're going to get fairly larger pieces as well. So that's why in this case, when we look at this side of the decimal, the thousands is essentially smaller than the hundreds and smaller than the tenths, okay? So now, when we're talking about getting smaller, we are then, again, we're moving from the left, starting at the left, and we move to the right to get smaller in value. To get larger in value, we move from the right to the left on our chart, okay? And when we're talking about powers of 10 here, these, if I multiply by 10, each one of these place value is then going to bump up. It's going to bump to the left. If I divide by a power of 10, then it's going to move to the right, meaning that the number then gets smaller, okay? So just think about that. Dividing is making smaller pieces. Multiplying is increasing the number that you have, okay? So so the number of times that I multiply these numbers by 10, or power of 10 right here, will tell me how many times I need to move this, will tell me how many times this place value will either move left, or if I divide it by a certain number of powers of 10, it's going to tell me how many times then that I need to move it to the right, okay? So let's go into a little bit of practice of that. So in class, we talked about, we came up with this little game, or this story in which we have two characters. And one of my characters we named Little Decimal, okay? And the other character was Power of 10 Man, okay? And I think we said in class Mr. Power of 10, but I changed his name to Power of 10 Man, okay? I just thought that sounded a little better. All right, so in this game that they play, Power of 10 Man tells Little Decimal how many times he needs to jump, or where he needs to move, and which way he needs to move, okay? So we have Power of 10 Man, and he's like, Little Decimal, you need to move 2 spaces to the right, okay? So if we have a problem that looks like this, okay, then we have our base 10 here, and then he's letting us know our power of 2 is letting Little Decimal know how many places he needs to move. Now, this multiplication, again, like I said, when you're multiplying or making your number bigger, that means the place values will then move to the right. So if he's saying that Little Decimal, will move to the left. So he's telling Little Decimal to move to the right. So that means my place values are going to increase their value by moving to the right, okay? Because again, like I said, when you are increasing your place value, that means you're moving to the right on the chart, okay? And we'll talk more about how those relate to each other as far as Little Decimal moving to the left and the place value moving to the right in my next slide. So in this case, Power of 10 Man is telling Little Decimal to move 2 places to the right, okay? And we know that because right here is showing how many times he wants Little Decimal to move. So Little Decimal's like, okay. So he shrinks himself down into this number here, 2 5/10, and he jumps 1 place and 2 places, all right? The value of this number is powered up, okay, because we multiply. The value increases when we multiply by a power of 10. When Little Decimal moves 2 places to the right, the place value moves 2 places to the left on the place value chart. So they kind of work opposite directions. Your place value increases by its value by moving to the right, while Little Decimal moves backwards or moves to the left, okay? And he pushes those numbers up in the place value chart, making them increase their value. All right, so let's take a look at that, and so that you can understand more about what that looks like. So here we have our same number, 2 and 5/10. We have 2 because I'm dealing with 2 ones. It's in the ones place, all right? And here's little decimal right here. He's giving us the thumbs up that he's all good and ready to jump. And then we have 5 that's in the tens place here, okay? So now let's see him jump. So now if he jumps 1 time, that put him behind the 5, right? Then he jumps 2 times, and that puts him back another place value. So then what does that do to our numbers? Okay, so that means that, I'm sorry, that should have been over here. So that means our 5 will then move 2 times. Our 5 will move 2 times going to the right, to the left. Okay, so that means the 5 then says, okay, let me move 1, 2. So now that means our 5, I'm sorry, let me go back. And then that means our 2 would move 1, 2. It would also move 2 places to the right as well, to the left as well. Okay, so our 5, let me say that again. Our decimal, little decimal, moved 2 places back or to the left, to the right. 1, 2. Then that means that our numbers in their place value moves 2 places to the left. So that would be 5 would move 1 in 1's place. Then it would jump again in the 10's place. That was 2 place values. It just moved 1, 2. Okay. And then our 2 would move as well because it can't stay there. It has to move as well. So that it started out in the 1's place. So it would then move 1, which will put it in the 10's place, and then it'll move again 2 in the 100's place. Okay. So that would mean it would look like this. My 2 would go in the 100's place. My 5 will be in the 10's place. And there's nothing in the 1's place, so we fill that with a placeholder or a 0. Okay. So now 10 times 10 equals 100. 10 to the power of 10 is the same as 10 times 10. So 10 to the power of 2 is the same as 10 times 10. Let's see, I multiplied 10 twice. Okay. And just like we said in the very first slide on that power of 10 anchor chart, 10 to the power of 2 is the same as 10 times 10. And I should have 2 zeros in my answer. 1, 2. 10 to the power of 10 equals 100. Okay. So now the value of your number should say your. So now the value of your number should be in the hundreds place. You should have your number be somewhere saying 100, like hundreds, okay? 10 to the power of 2 means move the decimal 2 times. So that's what we did. 10 to the power of 2 times 2 and 5/10 is 250. See, I'm in the hundreds now. I moved it 2 times. Because I'm to the right, because I'm multiplying and I'm powering up. So that means my place values move, my numbers move 2 times to the left in the place value, which increase their value, making them in the hundreds place, giving me the answer 250. Okay. So see, I have 1, 2, 3, 1, 2, 3. See, 10 times 10 is 100. So 10 to the power of 2 times 2 and 5/10 gives me 250. I'm in the hundreds now. Okay. Multiplying by power of 10 means make the value of the number more. Okay. Decimal moves to the right. Numbers move to the left on the place value chart. So you powered your numbers up. You made them stronger, okay? Or bigger or more valuable or just more, right? Dividing by a power of 10 means make the value of the number less, meaning I have less money, less amount, less value. Decimal moves to the left while the numbers move to the right. So it switches, making your muscle or your number power down, make it smaller, okay? So it powered down, right? So now let's look at this problem here. So we have 10 to the power of 2 times 2 and 82 hundredths. That's how I would say that, 2 and 82 hundredths, because my 2 would be in the hundreds place. So I say 82 hundredths. Okay, I got 2 wholes, 2 whole ones, and 82 hundredths. Okay. So that means then I would have to move this 2 places. I would have to move my decimal 2 places to the right, which would make my place values move 2 places to the left, okay? Increasing their value, all right? So let's move our decimal 2 places to the right so that my place values can increase by moving 2 places to the left. So that's 1 to the right, 2 to the right, okay? So that made my number bigger because 10 times 10, which is 10 to the power of 2, is equals to 100. So that means my number should end up in the hundreds place, right? So there I have 282. So instead of having $2.82, I now have $200.82. I'm sorry, $282, okay? I'm trying to find the relation between money and decimals because they're the same thing. It's the same thing. You understand that having $282 is more than having $2.82. And I was able to increase that by multiplying this decimal here by a power of 10, which was 10 to the power of 2, which is the same as saying 100, right? So then my answer should be in the hundreds, okay? Now let's do this one. This one is saying 10 to the power of 2 divided by, now this one would be said 45 and 623 thousandths. That's how I would say that because my 3 is in my thousandths place, hundredths place, tenths place. So when I say this number as a whole decimal or as a decimal, I would say 45. That's my whole, right? 45 wholes and 623 thousandths. Okay. Notice I said thousandths with that TH on the end. Okay. So how then would I do this one? Well, we're dividing, meaning that we're making this number smaller. We are powering it down, okay? So that means my decimal would move to the left. Little decimal moves to the left now because he wants, power of 10 man wants him to move 2 place value or 2 spaces to the left so that we can power down this number and make it smaller, okay? So that's 1 time, 2 times, okay? I'll do that again. 1 time, so that means it will be right here between the 4 and the 5, and then it's gonna move again, so now it should be in front. So now I have this number, which would be let me see, 45,623 hundred thousands. Okay, that's what place value that we put in. And again, we won't really jump into 10,000s and 100,000s or anything like that. But you will get some numbers that has that place value. As long as you understand how to move this decimal, you can do any number. It doesn't matter what number it is or how far it goes on the number on the place value chart. Long as you know how to move this decimal back and forth based on the power of 10, and long as you understand that when you move that decimal, then the value of that number changes on the place value chart, then you're all good to go. So just follow that given rule, that golden rule of moving little decimal back and forth based on whether you're dividing, powering the number down, making it smaller, or whether you're multiplying, powering up, making it larger. And again, you can agree that 45 and 623 thousandths is bigger than this number here. This is a very small number, right? When we see this, we think that's pretty small. That's tiny, right? So now here are some other practice problems that you guys could do. I'm going to be sending this over to you to work on. And if you have any questions about it, be sure to let me know. Some of these have power of 10 to the power of 5, 10 to the power of 6. Again, don't let that scare you just because I've only focused on 10 to the power of 2. Go back to the chart where you have those different powers all the way up to 5 and 6, and understand how that's telling this little decimal how many times he needs to move. Also understand that if I'm multiplying, then this number should be bigger, right? This is making this number a big number, okay? If I'm dividing, then this should be a little tiny number. So that means my decimal is moving to the left. It's making my number smaller, 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 okay? So it should be really tiny, and it should show that. So make sure that you still use that rule no matter how many times you're powering this up or down. Make sure you use those rules, and you can do any number that's on here. Okay, go back to the slide if you have any, and make sure you understand that. Jot it down so that you can have some notes to go off of as you're working through these problems. And let me know if you have any questions. I hope you enjoyed this lesson. If you have any questions, again, just reach out to me. And I'll see you in the next video. Bye.